Topic number 16, lecture discussion. Welding cast iron and hard surfacing steel. The objective of this topic is to know the factors which must be considered to weld cast iron or surfacing steels for wear or restoration. Welding cast iron. Cast iron is made by melting scrap iron and pig iron in the presence of coke and pouring it into molds, usually made of sand. It has a high carbon content, some of which is combined with other elements, and some of which is not combined. There are several types of cast iron. However, gray iron is more widely used than any other type. Iron castings have a tough skin, which may have flaws such as air holes and mixed-in foundry sand. It is brittle, it will break rather than bend when hit with a hard blow. The dark gray appearance of the broken surface is due to the free carbon and is the reason it is called gray iron. Cast iron is difficult to weld because the heat of welding can cause some of the free carbon to combine with other elements and make the casting more brittle. Welding is done on cast iron in the manufacture of new parts, repair of faulty new castings, and repair of castings which have been broken during use. Production welding and foundry repair welding are done under carefully controlled conditions. This produces satisfactory parts with little or no scrap. Your main concern with welding on cast iron will be in repair under conditions which may be different for each weld. Although each welding job will likely be different from the last, there are several procedures which must be considered on all jobs. When possible, get information from the manufacturer of the casting regarding welding procedures. Joint preparation for cast iron is similar to that used for steel. V-grooves should be somewhat wider, 75 to 90 degree included angles. The skin must be ground back from the edge of the groove, also from the root side, if welding is to be done there too. The joint may be formed by chipping, chiseling, or grinding. The weld area must be clean, free from oil, paint, and so on. If possible, heat the joint to 1,000 degrees Fahrenheit for a few minutes. This will drive off the absorbed oil, gas, and so on. And then, if possible, preheat the entire part to 600 degrees Fahrenheit. Small parts, up to about 30 pounds, can be heated with a torch. If no furnace is available for large parts, make a simple brick-enclosed oven and heat the casting with a charcoal fire. It will produce just about the correct preheat temperature. Weld while hot, cool slowly. If it is not possible to preheat, run short beads 1 to 3 inches at a time. Peen each bead with a ball peen hammer before it cools. Wait until the casting cools before running the next short bead. You should be able to hold your bare hand on the weld area before starting each bead. Never allow the casting to become cherry red with heat from welding. It will cause the casting to become more brittle and probably crack. When filling a joint in cast iron, it is a good idea to first coat or butter the entire surface of the joint with light penetration string beads. Then run the root bead followed by the remainder of the weld. 4 of the types of electrodes available for arc welding cast iron are cast iron, copper base alloy, nickel base alloy, and mild steel. Their selection depends on machinability of the weld, color match of the weld to the base metal, and the strength of the weld, and the ductility of the weld. Cast iron electrodes produce a good color match. The weld is as strong as the base metal and is machinable with proper preheating. 2 types of copper base electrodes are copper tin ECUSN A and C, and the copper aluminum. Of the two copper-tin base alloys, the ECU SNC provides the stronger deposit with higher hardness. The ECU SNA electrode has less tin content, is more of a general-purpose electrode, and produces a ductile weld. The copper-aluminum electrode produces a stronger weld and is used on the higher-strength alloy cast irons. 4 types of nickel electrodes contain varying amounts of nickel, iron, and copper. They produce welds similar to the nickel or nickel-iron electrodes. They do not provide a good color match. Mild steel electrodes, classified as EST, are used only when machining is not required. The weld metal picks up carbon from the cast iron and becomes too hard to machine. A common type of weld that you may be asked to do is a cracked engine cylinder block. In this case, a part of the casting is not broken off, but it is cracked through and allows water or oil to leak out. First, drill a hole about 1/4 inch diameter through the casting at each end of the crack. This will keep the crack from enlarging. With the point of a larger drill, about 1/2 inch diameter, countersink the holes to where about a 1/16 inch length of the 1/4 inch hole is left. Chip or grind a V-groove between the chamfered holes, leaving about 1/16 inch of metal at the bottom of the groove. Remove the casting skin next to the groove. Thoroughly clean the casting. If necessary, heat the area with an oxyacetylene torch to burn off the oil. Brush clean and repeat until there is no sign of oil. Weld short beads with the high nickel ENIC1 electrode. Peen while hot. Coat or butter the surfaces of the joint first, and do not overheat. Although each job may be different from the last one, and you may have to overcome a new problem each time, here is a review of the things you should do each time. Make sure the metal is clean. A good weld cannot be made on a dirty joint. Preheat the entire part if possible. Weld while hot and cool slowly. This will help keep the metal from becoming brittle at the weld. Select the proper electrode. When welding parts that are not preheated, be patient. Don't overheat. Weld a little at a time, and peen the weld beads while still hot. With study, practice, and experience, you will be able to make satisfactory welds on cast iron. Surfacing is a welding process for coating steel with an alloy that resists wear or corrosion. It also includes building up surfaces that have been worn to increase their life. Surfacing is often applied to new parts as well, for the same reason. Sometimes the new part is allowed to wear a little before the surfacing is applied. Badly worn parts can be saved from the scrap heap by building up the worn area with a build-up type electrode. Parts that do not need machining may be used as built-up or surfaced with a harder material. The electrodes used for build-up produce tough material which will resist shock loading from heavy blows. It can be applied in any thickness required. The electrodes used for surfacing produce a very hard material that will withstand wear but not shock loads. They can usually be applied only 1 to 3 layers thick. Electrodes are available in a range that varies from tough to hard. In the middle range, the material has some of the hardness and some of the toughness. Manufacturers of surfacing electrodes provide excellent information to assist in selection and use of the correct material or combination of materials. A typical example of one use is on the bucket or dipper of a shovel, backhoe, or drag line.